Well, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here, and great to have you here on a cloudy and rainy, but hopefully I put an order in for some clearer skies to come through. We'll see. It may be back ordered, but we'll see if we're successful. But anyway, it's great to see you here this evening. Let's see, by show of hands, who's here for the first time? All right, a couple of you. Anybody here members? Oh, for a number of others. Excellent. One of the things I always like to point out is that the people that raise their hand second have a piece of valuable information, and that's what a Kopernik membership can actually do for you. Kopernik belongs to what's called the ASTC, Association of Science and Technology Centers. And not only can you get into Kopernik on any Friday night and a number of our special occasions, but also with that Kopernik membership, you can get into over 380 other science centers. So if you like this kind of place, you could go to Robertson, you could go to the Museum of Science and Technology up in Syracuse, or the Intrepid down in New York City, which has a space shuttle down there, all for free. So it's definitely, in fact, in many cases, I remember a few years ago, I took my daughter down to the Franklin Institute in Philly, and had the two of us just paid the regular street price, it would have been more than the whole year's worth of admission for a family membership. So something to consider. So we've actually just finished celebrating our 50th anniversary of being a public observatory, but also an informal STEM education facility here in the Southern Tier. we do a number of things throughout the year. This morning we had was it second grade? We had second grades class in here learning about glaciers and water erosion. So not everything we do is always about talking about astronomy. We also do a fairly extensive summer camp program that starts for students that are entering, that are currently in first grade, sort of rising second graders up through high school. And these are week-long day camps that really focus a lot on hands-on. They're also sort of limited in the number of students we have, so that everybody really gets engaged in it. The other thing, we do have some other special events. One coming up is actually called Rocket Fest, and so every June we put this program together called Rocket Fest, where families will register for a rocket. They'll pick up their rocket and build it at home, and it's one of those Estes rockets with this the solid chemical engine in it, and then they will sign up for a launch window that they will come up. We'll have our rocket engineers check out to make sure that your rocket's ready to fly. If there's any field modifications, we've got a way to handle that. But then we'll put the rocket engine in, we take it outside, and you or your child is the one that presses the button that sends it up 500, 1,000 feet into the air. So that registration actually opens up tomorrow at 10 o'clock. So last year we launched, I think, 113 rockets, and we got room for 150. So, but don't wait. I think it's going to be very popular this year. A lot of what we do is always on our website. So if you look here, right now we're showing up our Kopernik Friday night programs. We talk about our summer camps. We have a program called Kopernik Kids for kids that are between ages 3 and 6, and that's a once-a-month program. I believe this next session and the following is sold out, but we will be starting up another session in July, and we'll open that up and let people know when that happens. But anytime you come up here to our website, you can go to our classes, events, and programs, so we can look at, this is where our summer camps are. You can learn about what we're offering, all the way from the young engineers for grades 2 and 3, engineering for kids, super science, super kids help save the planet, discovering the beauty of patterns through art, astrobiology sold out, immersive innovators, which is doing VR and AR. Both sessions got sold out of that. And we are about to open up another session of our 3D CAD adventures. And a camp that I run is called Return to the Edge of Space, where these are 8th through 12th graders that will put together a payload for a weather balloon that includes GoPro cameras and some tracking devices. And we launch the balloon right from here. The balloon will then reach over 100,000 feet, basically 20 miles. And when you look at the cameras, when the balloon finally bursts and the package returns to Earth, we send a tracking team out to grab it. We look at those cameras, those images, and you can see the curvature of the Earth. It's really a lot of fun. And nail biting, because it's like, is it going to land in a tree again or not? So, but anyway, so that's what's coming up. As I said, we got Rocket Fest that will be opening up tomorrow, and we'll actually need to update our website to reflect that. But one of the things I really love about Kopernik is these Friday night programs. It's really an opportunity for all of us to continue our education. And in particular, I like to say that, especially for the youth that's in the area, here in the room, schooling, your learning doesn't stop at 12th grade or in college. It continues throughout your life, and you can see by the number of adults here that's really what's going on. And it's really an opportunity to, not necessarily we're going to turn you into an astronomer or an electrical engineer, but we just help you understand how does the world work, and maybe spark an interest in that you might want to pursue a little further. Which, and especially for your younger kids, it may be something that would ultimately turn into a career for you. So. we're very fortunate to have some great corporations, great educational facilities here in the area. And this week and next week, we're focusing on robots. And robotics is becoming really a very, very hot, very in-demand career path. And this is a great way to get started. And we're fortunate to have, this is actually their first time presenting up here, is the Saints Robotics team from Seton Catholic Central. And three of the team members are here today. And what I'm going to do is I'm going to pass it right over to you, to Leah, and I'll have you introduce the rest of your team, and we'll take it from there. So first, what we'll do is we'll get out of this mode and get to your mode, which I think was right here, right? Okay.
Hello, thank you so much for, I'll turn this on so you guys can hear me.
Yep.
Can you guys hear me? Or?
Yep. Just go ahead. Just talk.
Hello, we are 3 representatives from the Saints Robotics team from Seton Catholic Central, which is located in Binghamton, New York. We're so glad to have you here today and hope you guys like what we have in store for you guys. So first off, what is a robot and what is robotics? Because you came here to listen to us talk about robots for a while, but what is it? So a robot is a programmable machine that is designed to perform a variety of tasks, whether it's from human input with a controller or pre-programmed instructions. And these can be done automatically or through controller inputs. Robotics is a field that combines various aspects of STEM, which is science, technology, math, and there's also arts involved. And this helps people to design, operate, build, and use robots. And we do robotics competitions, which are essentially robots competing head-to-head against each other, or 2v2, or on its own. And these and the number of points and how they are scored are defined before the competition in a game manual or something. So about the team. There's definitely more of us, but we're fortunate enough to have 3 of our representatives here today. So Team 6454 Saints Robotics, that is our first tech challenge number, was started 15 years ago, and it was our 13th year in First Tech Challenge, which is our main competition that we do. The team currently consists of about 20 members, ranging from 7th to 12th grade, and is led by Coach Rogers and Coach Garcia. And let us introduce ourselves. I'm Leah. I am the president of the club, and my role is to make sure that everybody feels welcome and has a role in the club, as well as head of documentation and marketing and scouting.
I'm Liam. I've driven the robot this year, and I also am the lead builder. And then this is...
Hello, I'm Nolan. I have helped build parts of the robot, and I am a driver on the team who drives the claw, and yeah.
Oh, and then on the back of our shirts it has our roles as well as the people in our club. So what do we do? Saints Robotics creates machines to compete in 2 different robotics competitions, some of which are shown here. So our main one is First Tech Challenge, which is a worldwide competition with over 7,000 active teams all around the globe. And this is where teams build slightly larger robots than some of these. That metal one is part of our competition robot that made us get to states. We also do SUNY Broom Robotics Competition, which is a local competition where teams are represented from over a dozen local schools, and multiple smaller robots, like some of these on the right, are made to compete. So for First Tech Challenge recognition of science and technology. It's for students ages 12 to 10 or 12 to 18, and its main value is gracious professionalism, which essentially is where people try their best and be nice, kind, and respectful to all of their competitors, no matter how they place. And gracious professionalism is extremely important in not only FIRST but in our club. And because one example of this is because someone who is your opponent can also be your teammate for the next round, and you want to be on good terms with them and make sure that you are kind and respectful to them. This encourages collaboration, communication, and leadership skills all across the board. Another value is inclusivity, where First Tech Challenge and FIRST as a whole welcome students from all skill levels and backgrounds. This is an important part of our club, as with all of our roles, it creates different roles, and so if you could be good at building robots like these, but you could also have other jobs like art or social media. So not just building robots or coding, but there's a variety of stuff that you can also contribute to the team. So the First Tech Challenge format, which is the competition format for our first half of the season. Our first season runs from about September to February or March, depending on how we do or how we place. So the main people who drive the robots and are in the pit doing the competition is called the drive team. They're consisted of 2 drivers, which are right there, and they drive the base and the claw. There's also a captain who helps guide them to do what they do, and then a human player who helps put game pieces on the field. Each team is randomly paired up with another team, which makes an alliance, and they compete against another alliance. And in that competition, there's 3 parts. Each match is 2.5 minutes long, and the first 30 seconds is called the autonomous period. This is followed by a 2-minute driver-controlled period called tally-up, where the drivers work together to get as many points as possible. And the last 30 seconds of the tally-up period is called endgame, where the robot can do additional tasks to score extra points. This year, the robot had to hang onto a bar, but in previous years, we could shoot a paper airplane, which was really cool. Also had to hang, put additional element on somewhere, and then lastly, the alliance that scores the most points wins the round. And then for advancements, there's qualifying events, and this goes through all of the states, 28 different countries all around the world also do these events. And then teams that win a qualifying event go to regional state championship, where they compete for a spot at the World Championship in Texas. 3 teams from our region could advance to the state championship. And our region consisted of the entirety of upstate New York. The only thing that's not from New York the only teams that aren't in our region from New York are Long Island and New York City, who have their own separate regions. So I've been explaining a bit about how the game works. This will provide an overview about this season's challenge. Every year there are different challenges, so every single season we have a different goal to work towards, but this will be the game for this year.
Welcome to the First Tech Challenge 2024 to 2025 season game, Into the Deep, presented by RTX. 2 alliances of 2 teams each compete to retrieve and score samples into net zones, low baskets, and high baskets. Human players assemble clips onto samples to create specimens, which can be scored on the low chambers or high chambers. Each match begins with a 30-second autonomous period. Following auto is the 2-minute teleoperated period. The last 30 seconds of teleop is the end game. Robots may continue scoring samples and specimens, but can earn additional points by contacting the low rung, achieving a low-level ascent or high-level ascent, or parking in the observation zone. The alliance that earns the most points wins the match.
So that was a very basic overview of the season. There's a few other videos that are 10 minutes plus long that describe like all of the penalties and stuff. But for now, that's just a very basic overview of the season where, come over here. These are our main scoring elements. I don't feel like taking off right now. But without the clip is just a sample. With the clip is a specimen. And without the clip, with the clip is a specimen, without is a sample. With the clip, you can hang it onto the chamber or rung, and if it doesn't have the clip, then you put it in the basket. And this will be our main scoring element for the year. So additionally with driving the robot and trying to score as many points as possible, another crucial element of the season is called scouting. And this also, it can be the difference between winning and losing teams. Because even if your robot performs exceptionally well, if you don't have a great alliance in the end, then that could be the difference between winning the entire competition and losing the competition. To clarify as well, the qualifying events, like the actual event, is composed of two different parts. There's the qualifier rounds, where the teams are randomly assigned to each other, and they just compete at 5 different times against differently randomized teams. And then after that section, there's the playoffs, where the top teams pick which team they want to align with for the rest of the competition that day. And then after that, they continue with a double elimination style, and whatever alliance wins comes out on top and wins that competition. So along with scouting, scouts do a variety of things. They're like the social people, as you will with the competition. But really, whoever's not directly on the drive team, and even the drive team talks to a variety of other teams and strategize, but all people on the team who are at the competition and aren't on the drive team are responsible as scouts. They talk with other teams, make social connections with others, and help find robots that are potentially compatible with ours. Scouting also helps people in the real world with communication skills and making connections with other people. And these two images are our alliances from previous competitions. These guys, West Fulton Firebots, they helped us get to the state competition in Utica. And then GorillaBots are an exceptional team as well. They made it to Worlds this year. We aligned with them last year, and they were alliance to get to the state competition for our last season in 2024. So these are our past 2 robots from the past 2 years, McFlairbot and McTonebot. I'll hand it off to the drivers to talk about their favorite parts of these robots.
Do you want to start?
It's up to you, sure. So these 2 robots use the same base that we've transferred over from both years. And actually, the base is right here. We tore it apart and reused it for the SUNY Broom competition. But it's a we've basically perfected this setup for the wheels. And the wheels on this robot actually allow it to strafe side to side, which is really helpful, especially in those really tight spaces where there's 3 other robots around you. And any contact with them actually can cause penalties. So you have to be very, one tip to build a winning robot is make your robot very precise in its movements. You need to be able to fit in tight spaces.
Yeah, so I agree with what Liam said. And this robot is for our broom challenge, but yeah, we used it for FTC as well, at least the base of it. So is there slides that talk
Would you-
about the components?
Yeah, there's a little bit. Would you like to talk about for McFlairBot the vision system?
Oh yeah. So the vision system, which is right here, is essentially just a camera that looks at these blocks, and depending on their color, it changes what the robot does, because essentially what you needed to do was place a specimen, which was the scoring point, or this, into
Pixel.
the, or whatever you call it now, pixel, into a certain spot to gain points. I don't really have a field to show you at the moment, but that was autonomous, and it just
And
figured
then
out the color.
for McTonebot, would you like to talk about the tail?
So it's actually still on this robot. The slide on this robot could reaches I think 42 inches, and when it's driving autonomously, it's basically we don't have any control over it other than to shut it down. And if that claw got stuck on a bar, or if that claw were to swing backwards, our robot was so top heavy that it would actually flip over. So we took a servo and an aluminum extrusion, and we made a tail that would support its weight, and it helped us a lot in competition.
So now you know a little bit more about the competition. Here's a video of us actually competing and winning. So we can go back. So our robot, we are on the top left right here. That's Nolan in the hoodie. And for our autonomous period, we pick up those 3 blocks as well as the preloaded one and place it in the basket. And then you will see us do additional tests. We are on the Blue Alliance, and our alliance partner is this robot as well. And autonomous is, to clarify, is the pre-coded section of the match, which is used by sensor inputs and pre-coded inputs. And that's the first 30 seconds.
In 3, 2, 1. Start of the match, all 4 bots are in motion. 27329 appears to be getting a little bit hung up on the ascender there. Almost flipped over, no worries, they were able to save it. 12833, scoring 1 on the high goal, lining up for a second. How's Blue Alliance looking?
We have seen Enderbot score 5 specimens on the high chamber. They missed 2, though, on the sweep, so we'll go 3, 30 points. Saints, meanwhile, 3 high in the basket. They get their 4th. Will they score it? Just excellent work. 62-16.
Start of the teleop period, all 4 bots in motion.
So now this is the driver control
127
period.
to 35, advantage Blue, with Enderbots harvesting 2 more samples carefully off the floor. They've got to control 1 at a time. They kind of kicked 1 out of position, but it did the job.
You can see over here West Fulton hanging their first specimen up on that high bar. Meanwhile, Mechanical Meltdown continuing to fill up that basket.
Saints goes back to the high basket, speaking of baskets, with another yellow neutral sample they get from the bottom of the submersible. Enderbots making a run to their human player. Good communication from the Blue Alliance here as Enderbots looks to mix it up with Mechanical Meltdown, a near neighbor or cousin bot, if you will, here in the submersible, vying for control of more samples.
Yeah, once again, we can see over here on the Red Alliance, West Fulton having a little bit of trouble in taking some of those specimens. No worries though, they just picked up that next one. Meanwhile, their alliance partner, Mechanical Meltdown, has swept the floor of all remaining alliance neutral colors attempting to go into the Ascender to pick up the remainers.
Saints 64-54 in and out of the submersible. 159 to 83 lead for the Blue Alliance as we cross the 45-second mark in Teleop. Enderbots goes back to the high chamber with another specimen that's good for 10 points.
As we enter the end game here, we can see West Fulton Firebots lining up to hang. Meanwhile, their alliance partner, Mechanical Meltdown, also attempting to hang. How's Blue doing, Mike?
Saints comes back for one more basket, high 8 points to the Blue Alliance. Enderbots for another 10 to the high chamber. They're going to return to their human player one more time. I'll be interested to see if they can come around the corner and hang as well. Saints looks like they're not quite
That's a
up
level
yet.
3 for West Fulton Firebots.
So the exciting conclusion is that the Blue Alliance, which was us, won that match. I forgot what the Red Alliance score was, but I know that was one of our best scores of the season with 255 points. And for reference, one of the world records are in the 500s, and we competed against and with some of these robots that were scoring top points in the 400s. So the New York Excelsior region is a really competitive region, and we'd like to make our mark on with the region. We did this year. So yeah. So hand it off to the drivers again to talk a bit more about the technicalities of the autonomous period.
So, autonomous mode. It is the first 30 seconds that we program into the robot to score points without the drivers controlling the robot. So it's just the program that drives the robot for us, and we, essentially we put the samples into the bucket if we're on the right side, and then we turn the samples into specimens and put them on the bar if we're on that side, as shown by that picture there. And we had a pretty good autonomous, but none of this would have been possible without the Roadrunner or the library that we used to drive the robot around the field, and also because of our dead wheels, which just are wheels that aren't powered, but they have encoders which tell you essentially how far you drive and your orientation. So it lets us know where we are on the field so that we can program it to make adjustments, and so that we can just, make this possible.
And then our scoring for autonomous, what we did averagely or our best, it was pretty consistent, not the most consistent out of our robot, but it was still working pretty good. We could deliver either 4 specimens to the high chamber, as shown in the bottom right picture, or 5 samples to the high basket, as shown in the video. And we were very flexible with our alliance partner on what we did. One quality of a good robot and a good team, in my opinion and probably the opinion of others, is flexibility, because you have to work to your strengths and the weaknesses of your other team so that it creates a good teamwork and you can do good.
So our teleop, which is the remote controlled period, what we could do is either put the yellow blocks in the yellow specimens in the buckets like you saw in the video, or we could also hang the samples on the bar. And just like autonomous, the best thing you can do as a team is be flexible, be compatible with as many people as possible. And the first thing you should do though is watch out for yourself, because if you get penalties on your own end, that's points off on both of your teams. So what we did, which we learned 2 years ago, is add sides and other barriers to stop game pieces from falling into your robot, because in previous years we've had a piece fall into a robot and you can only control one or two or however many are specified in the game rules. And if you have more than one, that's a double penalty or a double possession, which is a major penalty and actually really hurts you and your alliance. And then on our sides, we actually decorated them. They're painted, and our robot was actually named McTone because our bus driver, Tony, he would drive us waking up at 4 in the morning to take us hours away, and then he'd actually come in and watch us, and then drive us home, take us to dinner, all the fun stuff. So we designed this robot in his honor, I guess, this year. And so I talked about the strafe wheels. The linear slide, it goes from 10 inches and extends to 42. And that's what allowed us to reach so high. And then talked about the tail. We also had 2 linear actuators, which were removed for the SUNY Broom competition. They allowed us to hang, which that was a major point score. But we actually originally had 1 linear actuator on here, and this year we added 2 because there was a lot more going on with our robot than last year. But the linear actuators are really cool because they're a design that uses a lead screw, so it's slow, but there's a lot of torque, and it doesn't slip. And we need that torque because that robot is not light. And we actually use that for endgame. It was a lot of the time it was a really close call on how far we are off the ground, and the announcers actually started making jokes about it. But all that matters is we hang. So.
And the robot could hold position without power, which is part of the game. This year they specified that we have to hold without power. And this was also one of the most reliable solutions to the challenge of having your robot completely supported on a bar for like even just a few seconds. Consistently, almost every single match that we've done, it was consistent in its 2-centimeter hang. Have Nolan talk about the code.
All right. So for our coding, we used Python, and we also used a library or an OpenCV called Roadrunner. And for our the majority of our coding was for the autonomous competition, or the autonomous part of the competition. But there are other competitions called for the SUNY Broom. When are we going to talk about that one?
In like 2 slides.
Okay. So, yeah. I mean, for these little robots, you can use Python or blocks. I used Python, but yeah. And that's about all. Oh, OpenCV is just a library that allows these dead wheels on the bottom of this. Yeah, I knew that. Anyway, OpenCV was essentially a camera that allowed us to use not a barcode. What's it called? An April tag to figure out how far away our
Scoring thing was.
Yeah. So, yeah, that's about all.
So, this slide shows the evolution of our robot. So the first picture, that's our next slide. So the first picture over here shows the robot after 1 week. We used pretty much the same base as our one from last year, and we keep doing that, but every year we keep improving and improving our robot, and we use it we use the same base, but we add like a ton of modifications, so much so that it's not really the same robot. And then this was when it was scoring its first points. This was when it was mostly done and had a different claw. And this one is our finalized version that we took to our state competition. Do you guys have anything to add or talk about the claw next?
Oh yeah, the claw. So do you want to talk about it?
Sure. So we start off with any of our ideas on the robot by prototyping and drawing it. Then we make our first design, which this one, the second one over, that was actually inspired by last year's robot, because we had a vacuum system. It was basically, it was those two wheels on it that were connected to a motor, and it spun, and it picked up these and brought it into the robot. It was a collection system, and then we had the arm actually reached into the robot and pulled them out. So it was basically, it was two separate systems that were working together to score points. We took that to competition. We realized as cool of an idea as it is, it didn't work well. The pieces were, the samples were, or specimens were too close to each other, and it would just push more around, cause double possessions. So we decided to go with a design that we've seen other teams that were doing better. Use a claw, and so actually there was a step in between those two middle pictures, and we originally had sandpaper on it, but the sandpaper wasn't giving us as good of a grip as we wanted, and blocks were slipping out, especially when we tried to hang them. So we tried electrical tape, and it worked way better. But during our autonomous, our robot would actually throw itself off, because on the back of the claws in the second image, it was just a flat piece of metal, and as the robot was retracting, it didn't have it had lift power, or hold power on the arm, so it wouldn't droop, but that was only when it was short. When it's extended, the weight was too much, it'd pull the arm down. So when we pull it back, it would catch and actually pull our robot forward, and I think it even flipped it over once. So even just a little change by cutting the ends at an angle allowed them to just slide off, and then we didn't have to worry about improving our hold power.
So that was the first tech challenge portion of our season. The rest of our season, which runs either February to March, depending on how we do with first, to sometime in early to mid-April, but we're gonna work on working on SUNY Broom Robotics throughout the year to improve our performance. But we also take part in the SUNY Broom Robotics competition. Unlike FTC, where the whole team focuses all their efforts on one singular robot, this is where different people can build their own robot. Everybody's encouraged to make their own robot or work in teams, and there's many different competitions to choose from. So the competitions are small or large swept away. That one over here, the big metal one that was McTone, is now a large swept away. And then there's small/large King of the Ring or a sumo bot. There's a maze solver, a forklift challenge, autonomous task, and line follower. So here are some of the fields of the competitions. The one over here, that is the forklift challenge. That taller plastic robot. This one is a forklift that got us second place last year. The one in the middle here is the autonomous task one. Liam worked on that one this year. This one is small and large King of the Ring, where I think this robot is the small King of the Ring. Correct me if I'm wrong. This one is the small swept away, which is the plastic version of the large swept away. And the large swept away is basically the same thing, except metal. And this is where you have to put you have to take ping pong balls and wiffle balls and take as many as you can and just dump them onto the other side. And whatever team has the least amount of stuff wins. Some other fields include the line follower, which is here, and the maze solver, which was our winner for this year from Nolan. So for our performance in these, for SUNY Broom, over the years, we've won or placed in 5 of the 8 total events. This year, thanks to Nolan's maze robot, he solved the robot, and he finished in 31 seconds. And for First Tech Challenge, over the years, we are 3 times finalist alliance, and we've also been the winning alliance captain last year, which took us to states. We qualified for the state competition twice, which was the past 2 years, and we were recipient of the Collins Aerospace Innovate Award and placed second place for the Innovate Award 2 times. Is there anything you guys would like to add about the SUNY Broom robots? And then all this talk about winning isn't just what you place. You also have to have a winner mentality. Winning mentality isn't just about how you finish or what place you finish in, but it's doing your best and being satisfied with all the hard work you put in and leaving it all on the field. You have to treat your competitors with gracious professionalism and keep your head up about stuff. Even if you win or you lose, you still have to keep in good spirit, keep respectful to your teammates, because that ultimately makes you a winner in that. And winners also don't fear failure. Winners view failure as a valuable opportunity to learn. And every competition we've lost, which was many, like a decade plus, 15 years or some, but we won a little bit, but we still lose. We made sure to talk with the winning teams to learn what made their robots work good, and we take some of that input and use it to improve about our ideas for the following year. So like all of our robots just have an evolution. We don't stop at just one design. Our robot keeps evolving throughout the years, throughout the week, throughout the season, so that we can have the best robot we can. And that is it. Do you guys have anything else to add?
Any questions?
So we'll go around with questions, I guess.
All right. Well, thank you, first of all, very much for the presentation. But do we have any questions? Oh, yes. Can we?
So, this one is programmed to do what, guys? Tell everybody.
So this robot actually chases around anything it sees to try, and in competition notices it sees the other robot, and then tries to push them off.
Oh, hold on a second. Let me just took the microphone from you so that the people on the live stream can hear you.
So this robot is a sumo robot, and what it does is it uses a sensor on the front to look for another robot, and when it detects anything within a certain distance, it drives at full speed and tries to push them off the ring.
This one's 5 inches, so if you're gonna
Yeah.
demonstrate it, get nice and close. Aim and make sure to warm you. Now you have to get pretty close, but then it should chase you around.
See?
Push you.
It doesn't stop until it's turned off too.
Yeah, it doesn't quit.
It'll run off.
Would you like to demonstrate the metal robot?
Sure.
And then whoever else wants to drive a robot, I think we have a section where we invite some of you guys to just drive robot around, get a feel for a controller.
I don't think we're gonna drive the metal robot. The control hub's dead.
Oh, no.
Oh man. That robot should be charged though.
Should be. This isn't my robot. I don't know how to work it.
Okay, good. It just takes like 2 minutes to boot up. And then you just gotta press like that button.
Okay.
And then it'll find it as it boots up.
Is it what code is it? Because during the competition we had trouble with that.
I'll have to look. I don't remember off the top of my head.
Well, because it was connected to like Caleb's from like 5 years ago.
How about your base solver?
Well, that one's pretty simple. When it hits a wall, it turns left or right depending on which one's farther.
It's using a touch sensor. So it just drives up, rams into something that takes a turn, depending on which one's the farther distance. These are 2 distance sensors inside. So
Yeah.
how do I make it ram into you?
First, somehow.
It's so simple. He built it in like 2 practices.
Actually, like one. There was, but
Yeah, we had
yeah.
way more complicated ones that lost. Right. So sometimes, complicated isn't better.
this was my secondary robot. My main robot was small swept away. I spent a lot of practices, but I got like 3rd in that one. So
The autonomous part, is that like AI based or is that like just hard code?
no, that's just hard coded. So
Oh,
we
it is?
code what it's gonna do, and then
Okay.
it goes to those positions and
Is it
performs
like-
action. There are some teams that did that, like the people that once Worlds had like this vision system that detected the block, picked it up out of the center of the field using a program, and then brought it over, and that's how, like, because people, though they are pretty good at driving, they aren't as good as a well-programmed.
Yeah, in fact, in the rules for autonomous, you weren't allowed to use artificial intelligence.
Oh, okay.
Right, they do have a lot of rules that try to level the playing field, but I'm sure that would have been helpful.
And for those who don't know, this is our head coach, Coach Rogers, and that's our assistant coach, Coach Garcia.
Yeah, so just to dive a little deeper into your autonomous question, the way that we are able to achieve
Why don't you let go the mic so that
the way that we're able to achieve autonomous functionality with the accuracy that you saw in that video to go to those exact locations is the boys installed these little dead wheels on here, right? And he was talking about those earlier. Yes, Nolan, you installed them. Yes, and they measure every time they spin around. They measure in like one rotation is like 1,000 encoder count, so it can measure down to like a millimeter accuracy. So we can tell it to go. So like the key is they have to set it down in the exact location every single time, and then from there we can tell it to go to this exact location, and we tell it to turn in certain radiuses, and they're able to achieve all of that spatial awareness for the robot to operate autonomously through using the Roadrunner API, which they program in Java. Okay. This is not my presentation. You guys are doing great.
So did you guys have to learn coding in Java, Python? You did it by yourself?
Yeah. For Python, I've taken a class on it, and for Java, I got help from my coach, and also I did some research on my own on how to do it. But yeah, generally I did. That's
For the SUNY Broom competition, I'm built and programmed a autonomous robot, which it did 3 or 4 tasks completely autonomously, and Coach Rogers actually helped me learn to program in Java, and it was actually a really great experience. It's really just the syntax. Thinking in code is something that can be really hard or it can be easy, depending on how tired you are.
sorry, please.
Nolan, you want to give the introduction driving?
I'm not a driver.
Yeah, so
well, So this stick is to move around, back, left, right, and this stick is to move the slide up or down.
And the goal is to
And
stack
the goal is
those
to
on top
stack
of each
them
other.
on top of each other. So, yeah. Oh, lower the slide.
There you go, perfect. Nice, forward. Good job. This one, I think this was second place?
Second place last year.
Yep, last year this one took second at the SUNY Broom competition. Over like 20 different robots. And that whole competition is all like local teams. So there's a team from Harpersville, there's one from Shenango Forks, Windsor, yeah, Sydney. They're all from around here, and it's a great, fun day.
We have a new driver.
Yeah, you gotta recruit this kid. He's good. Where do you plan on going to high school? Steve's accepting applications. Oh, St. Che is wonderful. He'll be on our team in how many years?
Going into fifth grade.
Oh, he's going into fifth grade.
We gotta wait a
So
while.
Nolan was our youngest member ever. He started in either fifth or sixth grade. But that's because we were out. So yeah, I would drag him over to the high school, and we started building robots together for a long time. His older brother and I took the team over 10 years ago.
This is really cool. Yeah.
Do
they have like
That comes off all the time, so
Yeah, this thing always just kind of.
me and like his tires.
Yeah, I think St. John's has like some Odyssey of Mind stuff.
There's the tech teachers are trying to start a
Oh yeah, they're thinking about starting a first Lego league maybe, or doing like a Lego robotics team. He was talking, and I offered to help him with that.
Oh, yeah.
I think that would be really, I think that would be great, and these guys are interested in also helping the kids. I don't know. I mean, maybe we could do like a little summer robotics camp.
Oh.
If we could talk these three into it. Maybe. I don't know. I'll have to ask them. if they're up for it. It's the first time I've even thought of it.
We registered 2 times. This one.
Really? Okay, sure.
This is all Lego stuff here?
That's just a Legos kit. That you,
Okay.
So they stopped making this specific Lego kit. This was the EV3. That one is the new kit. It's called the Lego Spike, and that's the educational kit. They also make like a
Better
personal.
for autonomous, and this guy is better. Well, yeah, generally it's better for
Remote
controllers.
control.
Oh, okay.
Right, but that's not running the stock Lego operating system. We actually put embedded Linux operating system on it, which is why it takes so long to boot up. It's all loaded on that card. It's called EV3.
Yeah.
So we left out a lot of tech details, like that deep kind of stuff, because we didn't really know what audience would be tuning in. And we didn't really want to tell you guys all about the programming APIs if you guys aren't software engineers. But these guys learn all of this stuff in the club, and yeah, we have really a great group, obviously, very smart group here.
The best one for
And they build all this stuff on their own. If you're wondering if it's me doing it, well, no, it's not. They're doing. There's no chance that one person could build 20 robots in a year, and that's what the team does. So they're doing it without me.
And also, the best for driving is probably the EV3. Or not the EV Vex IQ is
Oh, yeah.
what it's called, and it's very good for controller. A good one for autonomous is the Spike. Yeah.
Yeah, because it's a newer platform, so the sensors are better.
Yeah. And also,
Where-
there's a lower response, like a lower lag for the Vex IQ. Like this has probably like a quarter of a second lag.
The spike ones, however, are really good for if you're getting into robots because you can code these with Python and you can actually drive them. They're not only autonomous,
Blocks if you
but you can also do
but you
block
could,
coding.
or C++.
And you can actually drive these off of your phone if you write code on your phone like that.
Oh, really?
Yeah.
That's great. I mean, so like my kids every year, even when they were little, they got robotics kits for Christmas. And yeah, so my kids can tell you many years, every year that a new Legos robotics kit came out, that's what they got for Christmas. So that's what we do over Christmas break together. And the Spike, I highly recommend it. It's a great gift. And it's so much fun to build over break.
Actually, as it turns out, Kopernik actually uses Lego Spike
Oh, you do?
in our
Great.
robotics. And it's been extremely, even like we have third graders doing it, and they're starting to learn, graphically oriented programming, and then they start adding to that. Okay, so question for you all.
Where are you educationally, and like what grade are you in?
Oh yeah, we're all in 10th grade.
So you still have a couple of years before you figure out.
Yep. Yeah, exactly. 2 more years, and then we're going to Worlds.
All right. Well, unless there's any other questions, I thank you very much for coming out here and demonstrating, talking about your robotic program. It really is extraordinary how something, sort of that small and sort of semi off the shelf can be put together into a really great great program that ultimately, hopefully will, this would be the kind of thing that you will consider, pursuing as a career in the long term. And we've got places around here that use robotics. So go get your degree and come on back here, right? Again, I'm assuming, I don't know, I have to go check to see whether or not, but it's unclear that we have clear skies, quite frankly. But for anybody who is here, and especially for those who may be here for the first time, be happy to give you a tour of the scopes, and can show you some images that we've taken with our big 20-inch scope. So anyway, thank you all for coming up. Next week, we're continuing the robotics theme with the Southern Tier Robotics Club, and Art is one of the coaches of that. He's here, and so come on back. We'll see a sort of a different version. It's interesting to see how that competition was set up and how a lot of it really overlaps with what you'll see next week. But the robots are a different size. We'll put it that way. And so. Anyway, thanks again, and look forward to seeing you next week.